All right, okay, let's start. Okay, some students already asked about kind of exam one. Okay, so exam one will be either Friday or maybe the following Monday. Okay, this Friday or the following Monday. Okay, it will in the evening. Okay, so probably I will open it from 6 until maybe 11. Okay, so yeah, give you guys 5 hours. Okay, so exam one will take like 1 hour. Okay. So if it's on Friday, okay, the Friday class will be canceled, okay, so it will become kind of office hour, okay. So if it's on Monday, okay, so yeah, the Monday class will be canceled, okay, so yeah, and it's become office hour, okay. And so yeah, probably today probably we won't finish the chapter 5, okay, but definitely we can finish in the Wednesday, okay, and then Wednesday we'll vote, okay, so which day do you want to take the exam, okay. And another good news for you guys is the chemistry department okay, decided kind of have organic chemistry 2 okay, in the summer, okay, and both the lecture and also lab, okay. So in this case, if you pass organic chemistry 1, this center, if you want to continue the organic chemistry 2, you can take class in the summer, okay. And probably Dr. Sai, okay, will teach organic chemistry 2, and just keep in mind, okay, so summer class may be quite intense, okay, yeah. All right, so yeah, if you have any question, okay, please type in the chat window, okay. All right, and then we'll continue chapter 5, okay. So last time we learned the naming of alkene and also alkyne, okay, C bond, also tree bond, okay. So there's one special situation, the molecule has both alkene and also alkyne functional group, okay. So in this case, how do we name it, okay? So actually just change the suffix name to E9, okay? So E9, okay, in means the bond, okay, and then I means kind of a tree bond, okay. And one important thing is you need to label both the bond and also tree bond positions, okay. And also when you pick up the longest carbon chain, okay, you make sure that this chain containing all the C bond carbon and also C bond kind of the tree bond kind of carbons, okay. Yeah, that's right. Okay, so either Friday or Monday. Okay, so the exam one. Exam one cover 1, 2, 3, and those chapter 1 to 3, and also chapter 5. Okay, so we need to finish chapter 5. Okay. All right. Okay, so the example showed here. Okay, so although the last carbon chain should go this way, okay, but didn't contain this last carbon chain doesn't contain the second carbon of the C bond. Okay, so in this case, we will pick up the longest carbon chain, go to this direction. Okay, right, and then when you label the number, okay. Number chain, okay. So just see which one's close to end of the chain, and that will take the carbon number 1. Okay, for example, for this case C12 okay, close to the end of the carbon chain, and then that will become carbon number 1, and 1, 2, 3, 4, 5, 6, 5. Okay, right, and afterwards, okay, so when you give the name, okay, so you need a label location number for both in and also ion, okay. So the label like this way, okay, you put here the location number. For the bond case, so separated by hyphen and then followed by kind of hyphen and then location number of a tree bond, okay, and then followed by kind of a hyphen and also the ion, okay. Right, and there's one very special situations case with so if the both bond and also the tree bond are same distance from the both end, okay. So how do we number the carbon chain, okay, or carbon ring, okay? So in this case, keep in mind, okay, so the C bond will have higher priority. We want to give C bond a lower number, okay? Okay, so C bond the higher priority than CC3 bond, okay? So lower number for C bond, okay? But 3 carbons to the right. Yeah, 3 carbon to the right, okay? So that's become kind of propyl group, okay? That's the main carbon chain. Okay. Yeah, when you pick up the longest carbon chain, make sure that containing all the carbon of the bond or tree bond. Okay, so if you go to the left, okay, go to right, okay, means the carbon 4. Okay, so that's want to write the longest carbon chain. Okay, right. Okay, so there's one special situation. Okay, so the both bond and also the tree bond same distance from either end. Okay, so give you one example. Yeah, for example, this molecule. Right. So we have a kind of ring structure. Okay, so there's the double bond and the triple bond. Okay, right, and then no matter how do you kind of circulate. Okay, so that's give same distance. Okay, so something. Right, like I said. Okay, so you need to contain all the carbons. Okay, so right. So if we pick up this carbon chain, okay, we miss this guy, okay, right? Miss contain all the carbon of the C double bond, also carbon the C triple bond, okay. So the only way we can do it here, we pick up this carbon chain, okay. No necessary kind of longest one, okay. So remember last time I gave you one example, okay. So we need to contain all the carbon of double bond, okay. So this is the carbon chain you need to pick up, okay. Right. Don't forget, okay. So that's your double bond, also the triple bond, okay. So contain all the carbon, okay. Right. So we come back to these questions, okay. Right. So in this case, if we can number it kind of from double bond or from triple bond, okay. So but the double bond has a higher priority, okay. So in this case, we give double bond lower number, okay. Okay, so that should be kind of the 8-member ring. Okay, so that's should call the cyclo oct. Right. So for inline naming, okay, so you need put the location number between the kind of the in and also the root number. Okay, so cannot put before kind of the part name, okay, because you don't know which number for the C double bond, which number for the double bond, triple bond. Okay, right. So that's octane 1 in 5 ion. Okay, so that's the full name for this one. Right. Again, okay. So double bond, triple bond. Okay, so you need pick up long carbon chain, make sure contain both carbon. Okay, right. So if you miss one carbon, that's won't give kind of right one. Okay. Okay, and for the organic compound, okay, so this type of naming we call IOPAC, also called systematic naming. Okay, so actually before the systematic naming is developed, okay, so a lot of organic compound already be found all kind of synthesized, okay, so the people already give their kind of name, okay, and so they have their common name code, okay, so those common name still be used quite often in our daily life, okay. That's unfortunately, okay, and especially some the small molecule, okay, small organic compound, okay. And so in this case, in addition, you have to learn IOPAC naming, okay. So that's you have to also memorize some the common name for some small organic molecule. Okay. Here are some examples, okay. So ethene, people also call this kind of ethylene. That's common name for the ethene, okay. Propane, also people call kind of propylene, okay. And this one's kind of affine, okay, but most time, okay, actually people call it kind of acetylene, okay. That's just CC3 bond, okay. And so please memorize this the common name, okay, especially at least in the chart in our slides, okay. So those the still be used quite often in our daily life, okay. So I may test in kind of future exam, okay. So give you one structure, ask kind of what's its common name, okay. You need to list it for me, okay. So for example, probably 2 years ago, I also put here the acetylene kind of in the quiz, okay. So the whole class, okay, only 1 or 2 students gave me right here the common name, okay. So don't forget it, okay. Don't forget it, okay. All right, okay. So now we begin to study the naming of your heteroatom organic compound, okay. So that contain nitrogen, chloride, okay, bromide, okay, or kind of oxygen, okay. The first one we'll study is the haloalkene, also called alkyl halide, okay. So haloalkene actually kind of compound contain the hydrogen atom, okay, bromine, chlorine, bromine, iodine. And the general symbol showed here, okay, just kind of alkyl group bound to kind of the chloride or kind of the bromide iodine or kind of the kind of the chlorine, okay. And the naming actually kind of the note hard, okay. So yeah, you treated all the hydrogen as their prefix, okay, and then for the fluorine, okay, the prefix name called kind of fluoro, and then chlorine prefix name called chloro, and bromine prefix called kind of bromo, iodine prefix called the iodo, okay. And then just list some kind of alphabetic order with other substitute group, okay, like methyl, ethyl, yeah, isopropyl, whatever, okay. Right. And probably give you guys one easy example, okay. Okay, for example, yeah, this molecule, okay. So yeah, we have this is the longest carbon chain, okay, and so yeah, we number it, okay, so yeah, because methyl, bromo kind of same distance to both ends, okay, so we give the bromo kind of low for alphabetic order, kind of the lower number, okay, 1, 2, 3, 4, 5, 6, okay, all right, okay, so that should be kind of hexene, all right, and then for methyl, and then 3 bromo. Right, and then yeah, once we have all these components, okay, we put them together, okay, that's 3 bromo, alphabetic order, okay, 3 bromo, 4 methyl hexene. Yeah, that's pretty straightforward, okay. And then yeah, we will learn kind of naming of your nitroalkene, okay, nitroalkene kind of just the nitro group attached kind of the alkyl chain, okay. This group we call kind of nitro. And you treat nitro group same as the hydrogen, okay. So yeah, just put it as kind of this is kind of its prefix name, okay, and put nitro as prefix alphabetic order, okay, with other substitute, okay. Right. And here are more example, okay. Yeah, the first one, okay, so the longest carbon chain, still this one, okay, and then we number it from right to left because the 2 methyl group on the 3rd carbon, right, and then see the least here the chloro and also 2 methyl group, okay, alphabetic order before the parent chain, okay, that's become 4 chloro, okay, 3 dimethyl, okay, and then hexene, okay. Right, and the second example it has the ring structure, okay, so there are 2 nitro group on it, okay. And then we will number it, okay, so one nitro will take carbon number 1, another nitro group will take carbon number 2, okay. So it doesn't matter which one is number 1, number 2, okay, so okay, same number, okay, so and then you need at least some kind of before the part name, okay, become kind of 1, 2 dinitro, okay, keep in mind you keep them di, okay, so and the cyclohexene, okay, so make sure you also label their location number, okay. Right, so the last one kind of the more complicated, okay, because there are totally a 4 substitute group on it, okay. So there's kind of cyclo propyl, okay, and then 2 iodo, and then 1 bromo, okay. And then the key thing for this question, kind of last one is how do you number the carbon chain, okay, and then which carbon chain can write, okay. So this one actually kind of we tested kind of probably also in some kind of exam quiz, okay. So quite often people count this carbon, okay, so the carbon on the cyclopropyl, okay, as the carbon 1, okay, that's wrong, okay, because this carbon belongs to this substitute group, okay. The real carbon 1 is here, okay, so that's here real carbon 1, okay, so that's here should be built in, okay, okay. And then cyclopropyl, iodo, okay, and the bromo, which is kind of as prefix, and then put them in alphabetic order before the parent name, okay, so remember label their location numbers, okay. All right, okay, so now it's you guys take a turn to practice, okay. All right, let's try this one. Yeah, there's kind of triple bond in the end of your chain, okay. All right, anyone can take a try, okay. So try to put this compound name into the chart window, okay. Yeah, this one actually kind of not hard. Okay, so we are pretty much just arcane. Okay, so that's kind of triple bond. Okay. All right, anyone want to take a try? Don't worry. Okay, so yeah. All right, what's the name for this compound? Okay. Right, anyone want to take the try? Okay, put the name into the chat window. Pretty good. Okay, so yeah, just only one small mistake. Okay, so we have the two chloro. Okay, that should be dichloro. Okay, but the two chloro need to give both location number. Okay, both location number. Okay, should be a 3,3. Okay, dichloro. Okay, otherwise pretty good one. Okay. All right. Okay. So yeah, for this compound case, in future if you have one organic compound, want to name it. Okay. So yeah, the first you find the highest priority group. Okay. So for this one, kind of arcane. Okay, and then find the longest carbon chain contain this highest functional group. Okay. So that's we go this guy first. Okay. So that's the first thing you need to take care of. Okay. Don't worry about kind of 2 chloro. Okay. Temporarily forgot it. Okay. Right, and then next kind of we number this arcane chain. Okay, so definitely kind of 1, 2, 3, 4. We give kind of 33 one lower number. Okay, so now you can have the parent chain name. Okay, so should be 3 butane. Okay, okay, you need to give location number of should be 1 butane. Okay, you need to give location number for the 33 bond. Okay. So yeah, if you name it kind of built 1 ion, that's also fine. Like the data showed in the chart window. Okay. Okay. So next we take off the 2 the substance group. Okay. So that's you need to give location number for both substance group. Okay. 3,3 dichloro. All right. And there's hyphen between O and those 1. Okay. Right, so otherwise you can name it kind of 3,3 dichloro built 1 ion. Okay, that's also right. Okay, pretty good. Okay, pretty good. Okay. All right, and so for the common name of the haloarcene, okay, just called kind of arcyl halide. Okay, arcyl halide. Okay, so kind of for example for fluorine kind of arcyl fluoride. Okay, and then chlorine called kind of arcyl chloride, bromine called kind of arcyl bromide, and then iodine called kind of arcyl iodide. Okay, so for example, okay, so we do this one. Okay. So this molecule case with most time actually kind of people call it kind of isopropyl fluoride. Okay. Yeah, fluoride. Okay, so people want to name as kind of 1 fluoro 1 methyl ethene. Okay, so that's kind of 2 methyl. Okay, so just the isopropyl fluoride. Okay, that's it. Okay. All right, and so there are many kind of the polar haloarcene. Okay, all right. So turn off your microphone, okay, please. And so those use that the organic solvent. Okay, so and pretty common. Okay, so and so in this case we have to learn some Right, so we have to learn some the common kind of name for the polyhaloarcene. Okay, and the first one is the methane chloride. Okay, so please write down. Okay, so that's one of the most common organic solvent. Okay, so we'll use the methane chloride in our next lab. Okay, so the caffeine. Okay, so that's is kind of common name methane chloride. Okay. And occasionally, people also call kind of the dichloromethane. Okay, that's actually kind of is the IUPAC name. And another one, the 3 chloride replace the hydrogen of the methane. Okay, so And then this one actually kind of chloroform, okay. Chloroform, okay. And so actually no one call it kind of trichloromethane, okay. So yeah, 99% time, okay, people just call it kind of chloroform, okay. And there's one actual one, okay. So yeah, that's I forgot kind of to put on the slide, okay. So yeah, please write it down, okay. So all the 4 hydrogen of the methane is replaced by kind of chloride, okay. So CCl4, okay. So this one no one called kind of the tetrachloromethane, okay. Just carbon tetrachloride, okay. Right. Carbon tetrachloride, okay. Right, please write down it, okay, and then memorize the case. So those here that I may testing kind of in future exam or quiz. All right, okay. So next, we'll learn naming of alcohol, okay. So for alcohol naming case, alcohol we know that kind of just the OH group, okay, also called kind of hydroxyl group, okay, attached kind of sp3 hybridized carbon, okay. Keep in mind it has to be sp3 that hybridized carbon, okay. So if it's kind of the unsaturated carbon, okay, so like here. The OH group attached on benzene, okay, so that actually not alcohol, okay, that's called kind of phenol, okay. They have different the physical and also chemical properties, okay. So alcohol has to be kind of OH group attached kind of sp3 type hybridized kind of carbon, okay. Okay, so those here kind of 3 kind of 4 saturated bond, okay. All right, and then for the alcohol naming case, so we just use one example, okay, so to learn its naming, okay. All right, okay, so for this alcohol case, so first step case, so we'll need to find the longest carbon chain with the OH group attached, okay. So in this case, should be here. That's your longest carbon chain with OH group attached, okay. All right. So don't pick up this one, okay. So if you pick up this one, although it has kind of one more carbon, okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons, okay. But this carbon chain has no OH group attached, okay. You have to make sure that the longest carbon chain with OH group attached, okay. That's why it goes together the 1, 2, 3, 4, 5, 6, 7, 8, 8. This kind of straight chain, okay. Right, and then second kind of the give the number the the parent carbon chain. You try to give OH group a lower number, okay? So that means you number the carbon chain from the end close to OH group, okay? So that should be from right to left for this case. Okay, so now we can name this the parent chain, okay? So we give the parent name, okay? So 8 carbons, okay, should be the octane, okay, but to tell people there's kind of alcohol in the molecule, okay, so you need to change the final E, okay, into OL, okay, become octanol, okay, and okay, so more important, okay, so you need to give a location number for this alcohol, so that's on the second carbon, okay, so that's you can label that this way, okay. 2 octanol, okay, or you can put a 2 between N and also O, okay, so octan 2, okay, that's also fine, okay. Right, and then eventually we take care of the prefix, okay, so that's this the RQ chain, okay, so that should be the propyl, okay, so 3 propyl, okay, 2 octanol, okay, so that's the full name for it, okay. Right, so just the take steps, okay, so and the alcohol common name is similar to the common name of the alkyl halide, okay, so just become kind of alkyl alcohol, okay. So give you one example, okay. For example this one, okay. So that's the alpaca name should call kind of ethanol, okay. Ethanol, okay. So final E replaced by OL, okay. But here some people also call kind of the ethyl alcohol, okay. Ethyl alcohol, okay. So that's here the just the similar like alcohol halide. And the cyclo alcohol naming, okay, so let's move to another page. Yeah, we still use one example here to study a cyclo alcohol naming. Right, for example, yeah, this one. And so yeah, for cyclo alcohol naming, okay, just keep in mind, okay, because the OH group has highest priority, okay, so in this case, yeah, the carbon with OH group attached, okay, automatically take carbon number one, okay, so that's carbon number one, okay. And then you try to yeah, the number this string, okay, in the direction, okay, with second substitute group, okay, lower number possible, okay. So in this case, yeah, we go clockwise, okay, 1, 2, 3. All right, and then falling case, we have that should be kind of here, cyclohexene, okay, right? And because the alcohol group automatically take carbon number one, okay, so in this case here, you don't need to give a location number for the OH group, okay, so you don't need to put the one cyclohexene, kind of here, cyclohexene one, okay, so that doesn't matter, okay, because that has to be carbon number one, okay, but here you don't need to put here the prefix and also here the its location number before the parent name, okay, that's here 3, okay. Fluoro, okay, cyclohexene, okay, that's here the full name, okay, so yeah. Right, so the cyclic alcohol naming pretty similar to the open chain one, okay, so yeah, just only one difference, okay, so the always always take carbon number one, okay, and then you don't need to give location number for the OH group, okay. And so if there's the CC double bond or CC triple bond in the molecule, okay, so actually that's not hard, okay. So you need just change the AN to EN, okay. So if there's CC double bond, okay. So if there's the CC triple bond, change to Y, okay. And make sure you need the label location number for all the CC double bond, CC triple bond, okay, and also alcohol, okay. And here come kind of the questions, okay. So if we have kind of alcohol and those the C-double triple in molecule, okay, so which one will give a lower number, okay? So alcohol has higher priority than alkene, okay, so and also alkyne, okay, C-double triple, okay. So in this case, we try to give a lower number to alcohol, okay. So that's one example, okay. So show here, okay. So because alcohol kind of go just the close to the right end, okay. So that's we number this carbon as carbon number one. 1, 2, 3, 4, 4, okay, right, 5, 6, okay. And then when we name it, okay, pretty easy, okay, just kind of hexene, okay. But you need to give a location number for both CC double and also the alcohol group, okay. Right, so that like this, okay. For hexene 1, okay. So 4 indicate kind of the CC double bond position. 1 indicate kind of the OH group position, okay. Or we kind of the hex 4 in 1, okay. So that's also fine, okay. All right, okay. So now it's you guys the turn to practice again, okay. Let's try this one. All right. Try to name this compound and that's gonna be a C double in this molecule, okay. Again, if someone like, okay, so you can also put your answer into the chart window, okay. Take a try, okay. Someone want to take a try? For this compound, okay, so again, alcohol has highest priority, okay, so in this case, you need to pick up long carbon chain containing the alcohol group, okay. And so then we will name it, okay, make sure give you the location number for both the alcohol theta bond, okay, and eventually take care of the all the other substituent group, okay. Right, and anyone want to take a try, okay? Okay, so okay, so close, okay, but yeah, there are some mistake, okay, so yeah, this is hard one, okay, probably I will do it, okay, show you how to do it, okay. All right, so first, okay, so when you have one organic compound at hand, okay, so sometimes kind of there's are multiple functional group, okay, so all right, so the first thing you need to do kind of pick up the functional group with highest priority, okay, so that's the OH group, okay, here for this case, okay, all right, okay, so some people, okay, so pretty good. The last one, the pretty much the close case, that's right, okay, so the last one kind of right, okay, so pretty much, okay. All right, okay. So and then for this case, OH group has highest priority. In this case, we take out this part first, okay. The last carbon chain containing OH group, okay. This guy, okay. Take out this part, okay, first, okay. Just temporarily forgot kind of all the kind of attachment, all the kind of substance group, okay. And then next kind of numbered, okay. So we have CC bond and also OH group, okay. Keep in mind, okay. So CC bond has the high OH group, okay. OH group has higher priority than the CC bond, okay. So we try to give OH group lower number, okay. So that's something kind of little bit wrong with the numbering, okay. So we want to give OH group lower number, okay. So that means kind of we start from right to left, okay. 1, 2, 3, 4, okay. So go this direction, okay. So that's give OH group lower number, okay. Right, and the next kind of we kind of give the parent name, okay. So that's actually kind of okay, so this time I put okay, so 3 in, okay, and then 2 all, okay. Right, OR indicated there's kind of OH group, okay. Right, 3 in there's kind of C bond on kind of carbon chain OH group on the second one. So you get the location number for both, okay. Right, and then in the end, okay, we take care of that's right, okay. So we'll talk about a priority later, okay, priority or later, okay. So okay, okay, and then we take out kind of 2 second group, okay. So that should be 3, 4, bromo, okay, butene, okay. So right, so that's and so far you already learned a little bit about kind of priority, okay. So that's what we'll do kind of summary in the end, okay. So but just keep in mind, okay. So if there are kind of multiple functional group in one molecule, okay, so normally kind of we pick up the highest one, okay, highest priority functional group, give you the suffix name, okay. So all other use that kind of prefix name, okay. Arcan, and also C3 so double, okay. So change kind of AN to EN or YN, okay. Right. So that's we'll talk about more, okay. So don't worry, okay. Right, here's kind of another example, okay. So that's the cyclohexene, okay. So also has kind of OH group, okay. So this one actually kind of not hard, okay. So keep in mind OH group has higher priority than kind of CC bond arcane, okay. So we want to give OH group a lower number and then goes direction, okay. Give you the CC bond lower number, okay, and then let's go like this way, okay. 1, 2, 3, 4, okay. All right, that should be kind of hexene no, okay, hexene no, okay. So you need to give a location number for both the OH group and the CC bond, okay. So that's become kind of actually kind of for the cyclic structure, okay. So you don't need to give a location number for the OH group, okay, because they are the automatically carbon number, okay. But you do need to give a location number for the CC bond, okay. That's 3 hexene no, okay, 3 hexene. 3 means kind of CC bond position, okay. All right, and for the molecule case, normally maybe there are kind of more than one OH group case. So in the molecule case. So if there are 2 cotton di, okay, 3 cotton trial. And so if you want to name kind of diol trial, okay, so make sure again, okay, so you need the label all OH group positions, okay. And another difference is kind of you need to keep the final E, okay. So right. So example showed here, okay. So this one has kind of 2 carbon, and each carbon has the 1 OH group, okay. And then kind of 1, 2 ethene di, okay. So keep in mind, okay. So see here, okay, we keep the E, okay. Just for easy pronunciation, okay. So and so the next one kind of the 1, 2 propene di, okay. Last one has the 3 OH group, okay. So you need to give their own location number, okay. So 1, 2, 3, propene, okay, KPE, and then trial, okay. Right, and then for the OH group, okay, so on the adjacent carbon, okay, so normally we call kind of here glycol, okay, so that's short here, okay. I think glycol, kind of propene glycol, okay. And last one kind of here glycerol, okay, so yeah, all these 3 guys kind of here the anti-freezer, okay, so yeah, for example, yeah, they say it's kind of quite cold, okay, so yeah, people estimate that I think glycol you kind of here the gasoline, okay, so yeah, that's prevent kind of here frozen of here the gasoline, okay. Right, here's one example yeah, to show the cyclic here the dicol, okay. Right, so this one okay, so yeah, the note hard, okay. So again, yeah, you need give a lower number for the alcohol, okay, but yeah, these 2 alcohol, yeah, the kind of one is 1, another kind of 4, okay. So in this case here, we need to pick up the alcohol, okay, with the second group, a lower number, okay. So that's here the bottom alcohol, okay. That's 1, 2, 3, 4, okay. We don't go there from top alcohol. Otherwise, the top alcohol, okay, kind of here this methyl group at 3rd carbon, okay. Right, and then we just here name as kind of di, okay. That's here give location number for both, okay. So yeah, the different formula mono substitute the cyclic here the alcohols. You don't need give location number for the just only 1 alcohol. The 2 alcohol you need to give location number for both, okay. That's here 1 for cyclohexene diol, okay. And eventually take care of the substitute, okay. 3 2 methyl, okay. Right. Here's the classification of alcohol. Last class we learned the classification of the carbon, hydrogen, okay, and classification of the alcohol is very similar to the classification of alcohol. Okay, you need to kind of the what's the carbon touch kind of the OH group attached carbon. Okay, so if this carbon has only 1 alkyl group, okay, 2 hydrogen, that's be called kind of primary alcohol. Okay, and if this carbon has 2 alkyl group, 1 hydrogen, okay, so that's called kind of secondary alcohol. Okay. And in that case, so if there are kind of 3 alkyl group attached kind of this carbon, okay, so that's we call kind of tertiary alcohol. Okay, here are some examples. Okay, so yeah, the first one is ethanol. Okay, so yeah, this OH group attached kind of carbon, and there's only 1 alkyl group attached to it. Okay, so that should be primary alcohol. Okay. Second one is kind of isopropyl alcohol. Okay, so that's 2 alkyl group, okay, and then 1 hydrogen on this carbon should be kind of secondary alcohol. And last one, terbutyl alcohol, okay, so that's 3 alkyl group, okay, and then on this carbon should be kind of tertiary alcohol, okay. So yeah, again, you need to look at kind of OH group attached carbon, okay. So yeah, otherwise not too hard, okay. Right, physical property of alcohol, okay. So yeah, alcohol has both CO single bond and those OH single bond, okay. Both are polar covalent bond, okay. So that's here alcohol has the dipole-dipole interaction, okay. But more important for alcohol is the hydrogen bonding, okay. So we have the OH interaction, okay. So that's the hydrogen bonding. We know that kind of the stronger than normal dipole-dipole interaction, okay. So that's why the alcohol has higher bonding point and also melting point than kind of aldehyde ketone whatever, okay. And the OH group is kind of the highly polarized, okay. So that's why the alcohol kind of hydrophilic, okay. And especially some kind of low molecular kind of alcohol, okay, so they can dissolve in the water, okay, in any the ratio, okay, like methanol and also ethanol, okay. Right, and then ether, okay. So now we'll start kind of learn the naming of ether, okay. So ether has a similar structure as alcohol, okay. So the alcohol the alkyl group and then oxygen and then hydrogen, okay. So that's alcohol, okay. And ether, okay, so just 2 alkyl group attached to the center oxygen, okay. So for the ether, okay, so the really depends what's the 2 alkyl group, okay. So if the 2 alkyl group are same, okay, so that's what we call the symmetrical ether. If the 2 alkyl group are different, okay, so that's what we call the unsymmetrical ether. Okay. And here we learn the ether naming. First we will learn is kind of common naming, okay. So because that's kind of more common, okay. So people name the ether, okay. And if it's kind of the simple ether, okay, so we name it here, okay. So dialkyl ether, okay. So for example this one, okay, there are kind of 2 ethyl group, okay. So we can name it the diethyl ether. Diethyl ether, okay. So the structure just like this, okay, 2 ethyl group on it, okay. Right, and if we see the unsymmetrical ether, okay, so two different RQ group, okay, so we just see the name as kind of the RQ1, RQ2, and ether, okay, so yeah, this RQ1, RQ2, okay, just alphabetic order of these two RQ group, okay, and then we do the same thing for this molecule, okay, this ether, okay, so yeah, that's become kind of the ethyl methyl ether, okay, yeah. So just alphabetic order put before the ether name. Okay? So that's pretty straightforward. Okay. All right. And but yeah, for reality case, so the RQ group can be more complicated. Okay. So in this case, the IOPAC naming coming. Okay. So you can just use the common naming. Okay. So and so. All right, so here, so a little bit of focus on, okay, so that's kind of the hard part, okay. So each time, when we reach the ether IOPAC naming, okay, some students get confused, okay. Little bit of focus on, okay. Right, so that's ether, okay. All right, and so if the two R group are different, okay, so how do you name this ether, okay? So you need the first, pick which R group has a long carbon chain, okay, which R group, okay. For example, okay, so if the right R group, okay, has a long carbon chain, okay, so this one, okay, long C chain, okay, will be named as kind of a parent, okay, parent name, okay, and actually parent name just kind of a arcane, okay. And then the other part, okay, so this part, okay, will become the substituent group, okay. And the same like here the chloro, methyl, ethyl, whatever, okay. Stay tuned. Okay. And so will be used as kind of prefix, okay. Prefix, okay. All right. Here are some kind of example, okay. So for the prefix name, okay, so the ether group prefix name, okay, so the general name called kind of alkoxyl, okay, alkoxyl, okay. So see here, okay. So pretty much it's come from RQ, okay, so RQ you change YR to OXY, okay. So that's the common name, okay. For individual the ether group name, okay, actually we can do the similar way, okay. So if the only one carbon is can come from methyl, okay. So you change the methyl YR to OXY become methoxy, okay. So that's the ether name, okay, for the methyl, okay. So right. So example showed here, okay. So the diethyl ether, okay, dimethyl ether, okay. So we this one kind of a symmetrical one, okay. So doesn't matter which part we pick up. For example, we pick up last C3 as the part name, okay, become kind of methane, okay, and then the right part oxygen, and then C3, okay, become the substituent group, okay. So this whole part called the methoxy, okay, all from kind of the methyl, okay, right, and then the full name become methoxy methane, okay. And then similar thing for the second one, okay, that's the ethoxy ethene, okay. So this part ethene, this part ethoxy, okay. And then last one kind of actually kind of the real good example, okay. Show the kind of the unsymmetrical ether, okay. And then last part, okay, cyclohexene, okay, has more carbon, okay. So that's here we'll name this compound based on this part, okay. That's just cyclohexene, okay. And then last kind of 3 carbon chain with oxygen, we use as kind of prefix name, okay. Prefix name, okay. So 3 carbon, okay. So should be propyl, okay. But here we change the YL to the OXY become kind of propoxy, okay. And then full name become propoxy, okay, cyclohexene, okay. So that's the full name for this molecule, okay. Right. Okay. And now you guys can take a try, okay. Right. Yeah, try to name this compound, okay. Yeah, if someone like, okay, so you can also put your answer in the chat window, okay. Take a try. Yeah, this compound has the ether, alkyl, and also fluoro substituent group. So yeah. Right. So in this case here, the first step, you find the longest carbon chain, definitely kind of this one. Right. Okay. So that should be 9 carbons. Next, so you need the number of the carbon chain. So remember we learned in the class last time. So we try to give you the lower number for the first second. So from left to right or right to left. So this time we from left to right. Because let's give fluoro kind of on the second carbon. If we from right to left, give kind of this S group on the fourth carbon. So that's here. All right, so now we have the partner name. So nonene. So 9 carbons. All right, so in that quiz. So if you don't know the full name of the one molecule. So you provide some kind of partial name like here the partner name. So you earn partial credits. So all right, so next kind of we take care of the substituent group. Substituent group. So with 3 substituent group. So let's be kind of 2 fluoro. This one 6s. So those are easy one. But now it comes to this ether group. Right, ether group. So says from the methyl. So the ME. But because there's oxygen attached. So in this case the original should be methyl. Ether group easy naming. So you just find its original alkyl group name. Alkyl group S. So you change the YL to OXY. YL become OXY. That's methoxy. That's it. That's its full name. So like I said, change the YL to OXY. That's give kind of ether group name. Right, and then for this one should be the 5 methoxy. Right, and then we just list them kind of alphabetic order before the part name. So for this molecule. So the full name should call the 6-ethyl 2 fluoro 5 methoxy nonene. That's the full name. So a little bit complicated, but as long as you know the rule, shouldn't be too hard. And the ether actually kind of the compound also can quite often use as the organic solvent. And here are some kind of the common name. Unfortunately, you guys try to memorize. The first one just diethyl ether. Diethyl ether kind of because kind of so common. So the people just abbreviate kind of to ether. So normally people say kind of ether, just indicate is diethyl ether. Another two is kind of also common organic solvent. So one is kind of THF. So THF. So it's just tetrahydrofuran. But you don't need to remember it's the full name. Just remember its abbreviation. So THF. That's the 5 membrane. So 1 carbon replaced by oxygen. That's kind of THF. Another one is the 1,4-dioxane. 1,4-dioxane. 6 membrane. So the 1 and also 4 carbon, fourth carbon replaced by oxygen. So that's kind of 1,4-dioxane. And both are common name. So please remember that kind of the abbreviation. So THF and then 1,4-dioxane and their structures. So that's kind of the important thing. Right, and then in that case, so we will learn the naming of amine. So amine we already learned kind of in the previous chapter. So it's kind of coming from ammonia. So H3. So we replace one of the more hydrogen with kind of alkyl group. So if you replace one hydrogen. So with alkyl with primary amine, 2 become kind of secondary amine, and then 3 become kind of tertiary amine. So the key thing here. So we try to remember kind of how many alkyl group attach kind of nitrogen. There's the quaternary amine. So actually just kind of 4 alkyl group attached to center nitrogen. This time nitrogen become positive charged species. Right, and so yeah, called kind of quaternary amine, okay, but here the yeah most time okay people call kind of yeah, ammonium, okay. Ammonium, okay, so yeah, that's a more common name. Right, so make sure you know how to classify the yeah different kind of the amine, okay, and also alcohol yeah classification we just learned, okay. And here's the one very tricky questions, okay. So yeah, I yeah actually kind of yeah this question, I used in the yeah maybe 2 years ago the example quiz, okay, right, okay. Ask kind of yeah these two compounds, okay. So yeah the yeah left compound is either the primary alcohol or secondary alcohol, and the right compound kind of your primary, secondary, tertiary alcohol. Right compound primary, secondary, tertiary amine. Okay, so yeah. Right. So anyone know the answer? Okay. Try to type the answer in the chart window. Okay, for the last molecule, primary, secondary, tertiary, or kind of yeah for the right one, primary, secondary, tertiary. Yeah, classification of the alcohol amine. Okay. Right one is the primary. Okay, so that's right. Okay, how about the left one? Primary, secondary, tertiary. Yeah. Chapter 5. Okay, so yeah, I will give out chapter 5 homework. Okay, probably yeah this afternoon. Okay, because we pretty much done the chapter 5. Yeah, yeah, and you guys can yeah work on the homework. Okay, both the actual credit and also yeah kind of yeah online homework. Okay. All right. Okay, so that's the yeah common mistake. Okay, so yeah both kind of permitted. All right. So when you kind of assign the classification of your alcohol, okay, so you need to look at kind of the carbon, okay. Right. All right. So this carbon has a 3 alkyl group attached to it, okay. So that means kind of this should be kind of tertiary alcohol. And when you look at the nitrogen, okay, so you have the amine, okay, so you need to look at kind of nitrogen, okay. And to say what's attachment on the nitrogen, okay. So this nitrogen has 2 hydrogen and then 1 alkyl group, okay. So that's kind of primary. Okay, amine. Okay, so that's the very tricky question. Okay, so yeah, if you make a mistake now, it's fine. Okay, but make sure you know how to classify kind of in the future exam. Okay, so all right, so that's done the class today. Okay, so yeah, any questions?